Okay, good morning, everyone. I have coffee now, and coffee is an important tool that will help us do the work we need to do today. Welcome to our course, Astronomy 1010. I've hit record for the benefit of those students who slept through lecture, or maybe night students who won't be able to watch until later on. There's quite a few of us here, so as I mentioned during the preamble, what would be ideal for me is if you do share video, but if you mute yourself, which already most of you know to do that, mute yourself so that you can hear me clearly, but feel free to comment and ask questions and interrupt me. Just unmute yourself when it's time for you to talk and then mute yourself again. With, I don't know, maybe 40 people here, maybe 50 if everyone logs in, it could create quite a bit of background chatter. So we should think about the proper etiquette. But sharing video, all of you like Henry and Juan and Tristan and Pedrobel, is great because then I can look at your faces. I see the Alex, is that you and your brother? Are you the ones who emailed me? Yes, are you guys twins?
Yes, we are.
Awesome, okay. Wait, so, you know, part of my cheat, Alex, is that I can see your names and your faces. So I'm gonna have to really struggle here. Which one is Alex and
I'm Alex.
And what's the other guy?
Jake. I'm Jake.
Okay, Alex and Jake. All right, you might want to keep those red and blue shirts on for me, otherwise this is going to get messy.
Yeah, we'll color coordinate for you for the first couple classes.
Okay, yeah, so you guys already know the drill from doing this. This is great. Alex and Jake. Okay, cool. All right. Hey, look, before we get into anything here today, before we start talking about the class and those things that you got to talk about at the beginning of a lecture, I want to start by sharing a screen and seeing if I can have a little more interaction with you guys. And I want to start with this function F5. Can everyone see my slides here? Alex, I can see your face right now. Alex and Jake, can you see the slide? Thumbs up. Okay, that's good. That's all I need. In fact, before we go any further, I'm going to do something. Everyone who doesn't share video, I refer to you as trolls. If you want to be a troll, that's fine, but I'm hiding you. Because if you're not interacting with me, then I'm not interacting with you. Good. Now on the side, I can see Alex and Greg and Matt, or Mateus, Matt. Okay, I'm just going to go with Matt. So I can see a bunch of you guys here. So if any of you aren't too shy and are willing to talk to me, I want to know what the heck you guys know before I start trying to teach you stuff. Now, Greg had better know this because he took my Astronomy 1020 class. If he doesn't know the difference between these two things, we're going to have some hard words after class. But how about the rest of you guys? Do you know what the difference between astronomy and astrology is?
Astronomy is looking at like the stars and like planets.
Yes. Okay, Andrew, how does that differ from astrology?
I don't really know.
Because I heard that people look at stars and planets in astrology too. This is why we want to clear this stuff up, you know?
All right.
No, but okay, so you know that astronomy has to do with stars and planets. That's good. But see, I was out drinking at the bar the other day and someone asked me what my sign was, and I think they were referring to, you know, like Sagittarius and Capricorn, and I'm pretty sure those are stars too, right? And then someone told me that Mercury was in Gatorade the other day, and I was confused about that, but I think they were referring to some of the planets. So anyways, I want to know if any of you guys know the nuance here. What's the difference between astronomy and astrology if they both have to do with stars and planets?
Astrology isn't the study of.
Pardon? Who's talking to me? Oh, I got a chatter here. Okay. Hava, you don't know. Oh, Liberty. Liberty's taken my class before. Hey, welcome to the second part of astronomy. Nice to see you again. Hi. Took me a second. Anyone, come on. There's like 40 of you here. So one of you SOBs have to know the difference between these two things.
Isn't, what was it? You said it was astrology and astronomy?
Yeah, just any kind of difference. It doesn't have to be super technical.
Isn't it like astrology is like the study of like the stars and like the shapes they make, right? Or like I know it has to do with something like with horoscopes.
Okay, that's the first part. That was good. So astrology, well, astrology has to do with horoscopes, right?
Mm-hmm.
astronomy might have to do with the orbits of stars, if that's what you meant. But when you say the shape of stars, most stars are spherical.
Well, yeah, I meant like,
Like here, right? Go ahead, Christopher.
like, like the shapes they make, like Orion's Belt or the Big or Little Dipper.
Oh, you're talking about the constellations, the
Yeah,
stick
constellations.
right. Now, both astronomers and astrologers care about those constellations, although for different reasons. I don't know, Liberty, you were about to drop some knowledge on this class, right? What were you saying?
My mic isn't working.
Oh, okay. There must be like 40 people in this damn class, and no one knows anything else about astrology or astronomy. I don't even believe you. I know you do, because when I'm out walking around the street, people are constantly asking me what my sign is.
I'll give it a shot.
Okay, sure. Alex?
Okay, so I thought that like astronomy was more the physical and mathematical scientific approach to looking at like the orbit of the stars and the planets and all that stuff, and astrology was more of a metaphysical and philosophical look of looking at it like the constellations mean this, you navigate off of astrology opposed to astronomy, and kind of more along that line.
That was a pretty good first stab, but believe it or not, Alex, even though you got the flavor of the feeling, you've made a couple of technical errors here. And the technical errors are when you described astrology as either metaphysics or as philosophy. And there's two reasons for that. Metaphysics has to do with the non-physical world, things that you cannot see or manipulate with your senses. Things in the physical world are like this ball here, or maybe even a planet or my hairdo. Those are things that you can adjust and manipulate and observe. Metaphysics has to do with intangible things that are, they're like hard to observe, almost like where does your soul go when you die, or what was before the universe, things like this that are thoughtful in nature, but you cannot directly observe them. Philosophy is a noble, I don't know, I guess you might call it an art, but philosophy itself is concerned with truth. And there's a reason why we don't consider, why philosophers do not consider astrology to be a philosophical discipline. And perhaps maybe I could explain it better if I did it like this, okay? I like to think of this as what your everyday astrologer looks like, okay? So this is a picture of what an astrologer looks like. And the message of astrology goes like this: everything's going to be great, you will be rich, okay? So those are the kinds of things that, that astrologers say. Now, on the other hand, this is what a typical astronomer looks like, okay? This is Edwin Hubble, who famously discovered that the universe is expanding. And the message of astronomers is different than astrology, because astronomers, their message is like this: we're all going to die when the sun enters its red giant phase. So you can see that the message of astronomy, it's not quite as uplifting as the message of astrology. Now, people tend to get these things confused. So maybe we could start by looking for some magazines to enlighten us here. You can read about astrology in a magazine like Dell Horoscope. You might find that in your supermarket magazine checkout aisle. And you'll learn all kinds of things in Dell Horoscope, like Uranus moves into Pisces, expect the unexpected. Or, I don't know, balancing mind, body, and spirit. Now, if you want to read about astronomy, you have to look at a different type of magazine, something like Science or Nature or the Astrophysical Journal. These are called peer-reviewed journals. And one of the first things you'll notice about the difference between these two things is there's a difference in price. You notice this thing costs about $2.50 and you buy it in the magazine rack. But if you want, they don't even put the price on this thing because they're so embarrassed by it. A subscription to Science might cost you hundreds and hundreds of dollars. And usually you try to get your employer to pay for it because it's so expensive. But you get what you pay for, because the quality of information in this magazine is much greater than much more rich than the quality of information in this magazine. And that's because it's something called the threshold for publication. If you want to publish a crazy article about space in this magazine, you probably walk into your editor's office with an energy crystal on your forehead and you say, bro, I am mad in touch with the stars, and I know about the deep cosmic connections between all living souls. And the editor is chomping on a cigar, says, I love it. 50 cents a word, your deadline's Monday. And that's it, you're ready to go. Okay, you're ready to publish in Dell Horoscope. Now, on the other hand, if you wanna publish an article in this kind of periodical, well, first of all, you got to go do something. You got to go out to your telescope here and you got to look through it and you got to record some starlight and collect some data and analyze it. And you have to test a hypothesis about the universe. And then you've got to write up your results with a detailed description of what you did and what you think is going on. And then you submit it to a body of enemy professors who are out to get you. And they comb through your research looking for any small technical mistake you might have made. And only after they've begrudgingly admitted that, well, the theory is misguided, but technically the research is sound, then you may publish in a magazine like Science. So it's harder to write something for this magazine than it is to write something for that magazine. That's a clear difference, right? And yet people tend to get these things confused because they both have to do with stars and planets and well, okay, the astrologers haven't figured out how to monetize the galaxies yet, but I'm sure that's coming. Okay, if not, I'm gonna do it, and I'm checking out with going on a sailboat ride. Anyways, here's an example of something called your horoscope. It's a depiction of actual constellations. These are real constellations. You know of them as your signs, right? Pisces, Aquarius, Capricorn, Sagittarius. And you may have even heard of the 13th zodiac sign, Ophiuchus, okay? We'll talk about that in a bit. Now, this isn't just made up stuff. These are actual real constellations that rotate through your sky night after night. They're real constellations and stars. But there's more than just 13 constellations up there in the sky, my friends. Hell, let's take a peek over here. Let's go to slide 50. The International Astronomical Union recognizes 88 constellations on the celestial sphere. Now, what's the celestial sphere? Well, we're going to have to talk about that, but here we go. The celestial sphere is like, if you look out from Earth in all directions, the sky, like the surface of Earth, is kind of a sphere that surrounds us. And there's only so many directions you can look out into space. It's 360 degrees, but in 3D, there's a difference. Anyways, there are 88 constellations that are splashed across this celestial sphere. My question is, why do astrologers, why are they so limited in their imagination that of these 88 constellations, they only care about 13 of them? Why do only 13 constellations matter? Some people are chatting me. Let's see what's going on in the chat thing here. Oh, Gabby seems to know that astrology is a pseudoscience. Yes, divine information about human affairs and terrestrial events. Now, okay, well, this sounds like right out of Wikipedia. I love it. Okay, astrology has, both astronomy and astrology study the motions of stars. Maybe it's time for us to take a note. What do you think? Let's go into note-taking mode. Wait, before I do that, let's see a show of hands. How many of you, if you're willing to be honest, this is your, how many of you have done a Zoom class before? I just need to know who knows what's going on here. Quite a few of you, right? I would assume many of you. Okay. Just in case this is your first time using Zoom, right now I am in gallery view, so I can see all your little faces like in Hollywood Squares, and I like to do that from time to time so I can see you guys laughing at my lame jokes. Okay, but when we're gonna take notes, what I do and what I think you should do is I go to speaker view, and then if you double click my little face box, it will go into locked speaker view. And locked speaker view is how you can hopefully read the notes on my board here. You should be able to see welcome to ASTR 1010. So let's take some damn notes, okay? Let's make some notes on the difference between astronomy and astrology, okay? So in this box, we'll put astronomy, and in this box, we'll put astrology. And what we want to do is we want to list some of the differences between them, okay? Okay, hopefully you guys can read that decently, okay? So the first thing that we learned is that astrology concerns itself with, depending on which branch you study, 12 or 13 constellations of the, get ready for your $10 vocabulary word, ching, you're about to get some of your money's worth right here, of the zodiac. The zodiac are the constellations that make up your signs, like Sagittarius and Capricornus and Aquarius, okay? Cha-ching, you just got some money's worth right there. All right. Now, astronomy is concerned with 88 constellations on the, here's a vocabulary word, the celestial sphere. And the celestial sphere is like the dome of the sky, but three-dimensional, okay? Okay. The question is, why do astrologers only care about 12 or 13 constellations? Now, I think it was Gabby, if I'm pronouncing that right, you can, if I'm not pronouncing that right, correct me. But Gabby said something about using the motions of stars or planets to divine human affairs. I like that. That's well said. Astronomy, on the other hand, is, I guess you'd say it's more of a, it's a physical science, or you might even say it's a natural science. There's a difference between physical sciences and natural sciences. Physical science, oh, Christopher Robin, talk to me, buddy. I see that you raised a hand.
So couldn't you say astrology is kind of religious?
No, you cannot. This is important. Philosophers make a distinction between religions, sciences, and what astrology is. The reason why is religion has to do with metaphysical questions, especially related to morality, like where does your soul go where you die, or suppose your neighbor has a dog and it barks in the night. Is it wrong to strangle that dog so you could get some sleep? Is that something that you should do? You really can't ask a scientist that. You might ask your rabbi or your guru or your priest or whatever, right? And those have to do with questions about, you know, suppose I don't give my kids lunch money. Does that make me a bad dad? I don't know. You know, you got to talk to your rabbi about that. Science is concerned with the physical world. Religions concern themselves, when properly applied, to the metaphysical world and the world of spirituality, things that you can't easily observe or taste or touch. They're different domains. But there's a problem with astrology. It's not a religion. And to understand why, we have to understand the central premise of astrology. Let's take a look at a very important slide. The slide I want to show you is 2 clicks over here. And it shows you why astrologers are concerned with only a measly 12 or 13 constellations. The constellations of the zodiac are the constellations through which the sun will drift over the course of 1 year. Now, I ain't talking about the sun rising in the east and setting in the west. That's different. That happens because Earth is spinning on its axis. And during the day, when the sun drifts through the sky, believe it or not, it's actually just kind of pinned to a particular location on the sky, kind of like pin the tail on the donkey. But if you watch the sun night after night after night for a whole year, you will notice that the sun travels on a giant circle through the sky, and night after night, it will drift through 13 particular constellations known as the zodiac. The reason why ancient astrologers and modern astrologers give these constellations so much significance is these are the constellations through which the sun drifts. And as far back as written time is gone, people have tended to worship the sun as their energy god. Think about the Egyptians and Ra, or Helios and his fiery chariot going through the sky. If you are an agricultural people, the sun not only brings you warmth, it brings food and life to your crops, and that sustains your entire civilization. So you could understand why ancient peoples might have gotten a little worked up about the sun. If the sun is traveling through these constellations, why then the logic goes, these constellations must be special or even magical. But no, it turns out they're not really that magical. They're just the constellations through which the sun is projected because of Earth's orbit. And all the other constellations that the sun doesn't drift through are equally as magical and equally as interesting for us to study and think about. So let's write down the central premise of astrology together. Let's clean this up and get it right. The premise goes like this. It goes, the location of the sun, as seen against the background stars. And here's the real kicker that should tell you everything you need to know about this. The location of the sun against the background stars on your B-day, and that's your birthday, will determine your personality type, and your destiny. This is the central premise of astrology. The location of the sun against the background stars on your birthday will determine your personality type and your destiny. Determines, I guess, if I want to use proper English, okay? Here's where we get to the reason why we cannot consider astrology to be a religion. If you look closely at this statement, everything in this statement has to do with objects that exist in the physical world. And hear me out on this. The sun. The sun is a physical object. Not only can we see it and observe it in our sky, but today we have constructed a spacecraft known as the Parker Solar Probe, which is traveling on a journey towards the sun and is going to fly through the outer atmosphere of the sun's plasma and scoop up particles. We are literally at the point in our development as a species where we are being able to collect material from our central star itself. Just think about that. That's insane. The sun is a physical object, and we have literally touched it with our spacecrafts. The background stars are a little bit more ambitious. They're farther away, and maybe one day we'll get there, but we're not there yet. But we can observe stars. We can observe and capture their light, and we can analyze their compositions. And it turns out that stars are physical objects that are made of the same materials as the stuff that you see around your world. Your B-Day, well, your B-Day really shouldn't be up for debate. If you have a birth certificate or a town hall record, you can find out someone's birthday, okay? And the personality type is a little bit squishy, but there is a field of psychology which attempts to understand personality types, and they, you know, they do an all right job, I suppose. It's still a young science, so they're working on it. And your destiny, well, if you just wait until you die, you can ask yourself, what did you do with your time here on Earth anyways, right? Now, it turns out that because all of these things are either physical objects or kind of factual statements, if you are a reasonable person, you can go out and you can compare the location of the sun against the stars on your B-Day, and you can try to measure your personality type, maybe with a Meigs-Bryer personality test, and you can examine objectively whether people's personalities have anything to do with their birthday and where the sun was. And it turns out that if you go out to do this, this statement is a false statement. It turns out that there is no relationship between what constellation the sun was in on your birthday and your personality type or your destiny. So sorry, kids, maybe you were born on Albert Einstein's birthday. That don't make you Albert Einstein, okay? And it don't make you Chopin if you have the same birthday as Chopin. I hate to break this to you. Now, you might be a very special person. You might be a unique raindrop in an ocean of rain, but it doesn't matter where the sun was on your birthday. In fact, to further compound the hideous lie that has been perpetrated on you, it turns out that the sun wasn't actually in the sign that they tell you it was on your birthday. And that's because the moon, over thousands of years, exerts these gravitational influences on the Earth that causes Earth to twist with respect to the stars. And that shifts where we see the sun against the background stars. So chances are there's like a 90% chance that whatever they tell you your sign is in the horoscope chart, if you check in your co-star and they tell you you're a Sagittarius, chances are the sun wasn't even in Sagittarius when you were born, because they're basing it off of a 2,000-year-old book, Ptolemy's Tetrabiblos. The sun might have been in Sagittarius in 50 AD, but it's not if you were born in 1992 or something, whatever damn year you youngsters were born in. Anyways, because astrology makes statements that do not hold up to self-scrutiny, you can't call it a religion or a science. In fact, as one of our fellow students pointed out in the chat box, philosophers have labeled it a pseudoscience because it uses technically gobbledygook terms like Jupiter in the second house of, Aquarius. And it tries, it bamboozles you with technical jargon that if you actually slow down and analyze what they're saying, doesn't make any sense or doesn't even work. It doesn't hold up to self-scrutiny. So basically, it's a modern day version of snake oil. And people love it, okay? Now, on the other hand, let's have a different thought here. This is what astronomers are concerned with here in slide 8. This is a legendary image from astronomy known as the Horsehead Nebula, a giant cloud of cold hydrogen gas floating in the void of space. This is what real reality is all about here, okay? Earth is kind of the exception. Most of nature are cold, thoughtless clouds of hydrogen gas and giant spheres of radiating plasma. The universe is way weirder than you might ever expect. And it doesn't seem to have to, at first it doesn't seem to have a lot to do with our everyday lives, although it turns out our lives are intimately connected to all of this stuff in ways that might surprise you. This is what astronomers are interested in, nature. And they're interested in observing nature and learning about this weird stuff. Maybe we should find out what's going on out there. That seems important, or at least interesting, right? In any case, I don't know what you guys are planning on learning this semester. I'm going to keep my expectations low. But let's start by learning one of the most important lessons that I have to teach you in this class. Astronomy does not equal astrology. And if you write me an email and say, "Dear Professor Britton, I am taking your astrology class. I am going to hit delete on my computer and I'm going to pretend like I don't know you," okay? So with that in mind, I'd like us to all recognize that you've signed up to learn about astronomy. And in fact, you're here to learn about a particular branch of astronomy, that branch that has to do with the solar system and all these wonderful planets that we're going to learn about. I will be your host through this journey. My name is Brendan Britton. I have a master's degree in astronomy, and I've been teaching at the college for many years. I know all sorts of useful things to enlighten you about the stars, okay? Here's a picture of me in front of the CCRI 16-inch telescope, which is at the Margaret Jacobi Observatory in the backwoods of CCRI. One of my favorite parts of this class is usually inviting students to come out and look through this telescope, but with the COVID-19 pandemic, that's going to be a little bit difficult / dangerous. So maybe if the semester is going to go on for 4 months, maybe if things get better, we'll actually get to a point where I can take you out to this telescope, but we're not there yet. Meanwhile, let's talk about you. I don't know who all of you are. I know a couple of students who've taken my other class. But if you keep your video chat on, I will get to, or your video camera on, I'll get to know your faces and your names, and I will treat you with the dignity and respect that you deserve because you paid $500 to listen to me talk about giant spheres of plasma and planets at the edge of our solar system. And thank you for your patronage. Now, whoever you are, I hope you show up to our class every Monday and Wednesday with the following 2 things. First thing you're going to need is a calculator. I already told you in the email which one you need. Hey, let me just stop share for a second. How many of you actually got the calculator for our first? I know I only sent the email a couple of days ago. That's my bad. How many of you managed to get a calculator before the class today? Could you show me hands if you got the calculator? Petrovel's got it. Frank, welcome back, Frank. There's another veteran of astronomy. Okay, so a few of you did, but not as many as I'd like. You might want to grab any old calculator today that you can find. I've got a ridiculous one over here. For today's class, any old calculator will do, but these kinds of calculators are no good. We're going to need a scientific calculator, all right? There are a lot of you taking this class this semester. They doubled the class enrollments, which means I've got a crazy zoo to manage. It is going to be critical that we all buy the exact same calculator or this class is going to grind to a halt and make everybody miserable. So we'll talk about that in a second. I hope you also have a positive attitude because remember, you guys signed up for this stuff. For some reason, you signed up to listen to me talk about the volcanoes of Mars and the Great Red Spot on Jupiter. I don't know why you did that. You all have your, oh, Matt, you got one. You got the Casio, right? Nice. Okay, I'm happy about that. We're going to use that. We're going to learn how to use that today. Remember that you signed up to learn about this stuff. And luckily for you, I'm not here to teach you QuickBooks or accounting. Thank God. Otherwise, I'd probably just take myself out back and shoot myself and be done with it, okay? I'm here to talk to you about cool stuff like the solar system. And the solar system is a cool place to be. We got Earth. That's where you live. And believe it or not, Earth is actually a very interesting planet. And although I personally got into astronomy so that I could get the hell away from Earth and as far outside of our planet as possible, it turns out that after you've plunked around on the other planets for a bit, you tend to look back at your own planet and realize that it's got some very cool things going on that make it unique and an interesting place to be. We're going to learn about the moon because everybody loves the moon. We can all see it with our eyes. We'll learn about the sun. The sun is a vital and dynamic part of our solar system. And we'll also learn about the 8 planets, no longer featuring Pluto. Hey, students, how many people out there know why Pluto isn't a planet anymore? I'm wondering if you know. Andrew, go for it. Or Austin, we'll try you next. Andrew, what do you say?
It's a dwarf planet.
That's right. Why did we have to make Pluto a dwarf planet? Why couldn't it just be a planet?
I don't really know. I just know it's a dwarf planet.
That's good. Well, that's something, and I'll take it. Austin, do you know why they demoted Pluto Christopher, do you know? I can't see everyone all at once. Oh, hey guys, let me explain what's going on my end. On my end, because I have my slides up, I can see a small segment of you. I can see maybe like 8 of you at a time. So I don't mind a little bit of chaos. If you think you know the answer, just start shouting stuff out, and maybe it'll be funner that way. So if 2 people are talking, we'll work it out. So if you think you know, someone tell me.
I think it's Oh, you can go first.
Weren't there like other dwarf planets found?
Yes. Wait, who are you? Who's talking to me right now?
Gabriel Scungio.
Okay, Gabriel, where are you? Oh, what's your last name?
Scungio.
Oh, okay. There's too damn many of you. Well, Gabriel, wherever you are, nice to hear your voice. Listen, yeah, they found other dwarf planets. That's basically the right answer. See, some people think it's because Pluto is too small, but we always knew how small Pluto was. That was never the issue. Morgan, do you want to say something?
Oh, well, I was going to say, yeah, it's too small, but also I remember something about its orbit being like too wide.
Yeah, but that kind of came after the fact. Here's what happened. If you studied the solar system back in the day, like your Grammy and Grampy took solar system class, they thought the solar system looked like this, and there were the 9 planets, and that after the orbit of Pluto, it was just the icy void of space until you get to our next star. But as telescopes got more powerful, we began discovering weird objects, icy objects that looked like Pluto just outside the orbit of Pluto. Things like Sedna and Quaoar, and who could forget 2003 EL61? Actually, today that's known as Haumea, I believe. They started discovering these things which are called Kuiper Belt objects. They're kind of giant balls of ice and rock that live out in the realm of the comets. And as they began to discover these things, they realized they had the similar composition to Pluto and were sort of the same size. And they were worried that one day they would find one that was bigger than Pluto, and eventually they did. They found, well, first they called it 2003 UB313. Then the astronomer who discovered it tried to name it Xena because he liked the TV show Xena Warrior Princess, and he thought that would be a cool name. Yes, Andrew's nodding his head in approval. But then the International Astronomical Union said, no way are we going to let you do that. And so eventually they settled on the name Eris, okay? And Eris kind of gave us a schizophrenic break because we had this problem. If Eris is bigger than Pluto, then it should be a planet, but if we let Eris in, then we probably should let all these other planets in. And then we'll have a problem where our solar system is like 8 normal planets, and then maybe they detected so many of them that they calculated that there could be up to 100,000 or maybe even 1 million of these objects. And then they started to realize, whoa, there's so many objects like Pluto out there that we have to think about Pluto differently. It's certainly an interesting world. It's large enough to consider it a dwarf planet. But they then redefined what a planet was. And yes, they did define it, whoever I was talking to earlier, based on the squishiness of its orbit. And importantly, a planet should be able to clear out its environment, kind of like a King of the Mountain game. It should have enough self-gravity and gravitas to sort of clear out its surrounding environment. And Pluto does not have that capability. Anyways, Pluto is still awesome. Just because it's a dwarf planet doesn't mean it's not cool to think about. And we'll learn about that as we go forward. If you guys want to learn about things like Pluto and Kuiper Belt objects, you're going to need to make a new best friend. And your new best friend is math. And I'm here to warn you guys that this class is going to involve a teensy bit of algebra in it. And the reason why is because astronomy is a physical science. And when we look up at the moon, we get excited about all these impact craters and all of these weird dark shapes. And we think, man, the moon is so cool looking. I'm so into that. But you can't get enough just by looking at the pictures. You eventually have to do something. And science ultimately has to do with measurement. That's what makes science different than other activities like basket weaving or accounting. Well, accounting has to do with measurement too, but it's not the same goal. Astronomers, like other scientists, perform measurements of their environment and their universe to understand what's going on. How big is Jupiter? How large is the universe? How old is the universe? These are questions that we're naturally interested in. Hell, if you look at a picture of Jupiter, this thing is awesome looking enough to inspire you to want to know more about nature. But you can only go so far just by looking at the picture and thinking about it. You're going to need to develop a taste for some boring things like studying diagrams to understand the relationships between things. And because of all these measurements and because of these relationships, we're going to need to do a little bit of math in this class. That way it's kind of like a real science course, not some watered down piece of garbage, okay? And that's why you're going to need to get yourself one of these. If you haven't done so already, let me introduce you to the Casio FX260 Solar Calculator. It is your friend in the Valley of Darkness. Now, you don't have to be particularly good at math to take this class. I'm going to assume that you're not good at math. All you have to be able to do is be a reasonable person who can find your multiply and divide keys and to push them when I say go. I'm going to tell you everything you need to do to succeed at this course. But I can't tell you which buttons to push unless we all have the same calculator. It'll just going to get way too complicated. I've found that even if some of you might have some math experience, maybe a few of you are or even science majors, this whole class is just going to run a lot more smoothly if we all have the same calculator. And let me tell you, this calculator is really cheap. You can get it, I believe, at like Walmart or Circuit City, or there's two different versions of it. Let me show you. I have both versions. This is the original one, which is here in gray. This is the Mach 1, all right? But some of you may have also come across the white version, which is the Casio FX260 Solar 2. They're basically the same calculator. There's even a hot pink version if you want the hot pink version. These calculators are super cheap and they're powered by the sun, which seems symbolically appropriate for our class, all right? And that means they're never gonna run out of batteries on you, and they've got all the buttons that we're gonna need in an easy to locate spot. Hey, Matt, how much did you end up paying for yours, and where'd you get it?
I actually already had it. It was my brother's.
Amazing. How about someone else who bought it? I wanna know what you were paying for that thing these days.
I got it at Walmart, and it was like $8 or $9 only.
That's awesome. So look, all of you have to go out, and hey, the brother twins, Alex and Jake, I'd actually recommend that you guys are probably used to sharing things. I grew up with a brother, so I understand this. But if you can afford it, each get your own so that you're punching the buttons together. I actually think that's gonna, all right, cool. That's gonna save you a lot of, that's gonna help you grow and learn together, okay? I want you guys, this is a big part of this class. When I tell you to start punching the buttons, that's your job. You punch the buttons, okay? And that's how you're gonna learn to do math and to be good at science. All right. Let's take a look at our, before I run out of time here, before we can learn about astronomy, before we can learn about the solar system, we're gonna have to talk about the classroom system. That way you guys know what I expect of you and how your grade is determined. So let's look at a few of our handouts. You'll remember that I told you guys that in Blackboard, you can grab your syllabus here. This is an important document that you can get from Blackboard. It's got useful information. This is how to contact me by email. Hell, this is my damn cell phone number. If you don't abuse it, you can text me or something if you're in a pickle, and I'll try to get back to you as quickly as I can. Hell, you can even call me up if you're in a real jam and we can talk. I don't mind that. I have to make myself more accessible because, you know, it's weird times now where we're all interacting on the internet. Our class runs from 11:30 to 1, Mondays and Wednesdays. Now, I talked to the twins about this. Some of you signed up for a lab that happens on Monday, and some of you signed up for a lab that happens on Wednesday. And that's how things used to work when we used to meet in person, because our lab would only hold about 14 or 15 people at a time. But I've got bigger and better plans for us now, okay? Let me explain how things are gonna work. We are all going to do our labs together on Monday In fact, we're going to do a lab today after class. And we're all going to do our homeworks together on Wednesday. See, by doing this, instead of having to do the homework on your own, the homework is going to be hard for you guys. I'm going to do the homework with you in the same way that I do the labs with you. That way, all the work for this course will just be in the freaking lunchbox. And once the class is done, you won't have to sweat it afterwards. You got enough things to worry about in this crazy world without having to stress out and try to do homework at night after you've had dinner. It's just going to be too much. So you're going to want to trust me on this. We hang out together. We do labs together on Monday. We do our homework together on Wednesday. And then everyone has all their work done and no one can screw this up, okay? So you're just going to have to trust me for a little bit. I know how to do this so that it's going to be good for you. Okay, let's talk about books. We have a textbook called The Cosmic Perspective. A few of you had some questions about that. Let's go to speaker view here. The version that most of you are going to want to get is The Cosmic Perspective, just the edition that says the solar system. Now, a couple of my summer students did make it through the class without buying the book, but that could be really stressful for you guys, especially come exam time. There's all sorts of stuff that is going to augment what I'm teaching you in class. We need the book for our homework problems, okay? You can get the full version of the text. The full version of the text is more expensive, and it contains 2 halves, the solar system half and the other class that I teach is on stars and galaxies. You could get that as loose leaf. You could get that as a digital version, whatever. But if you're going to buy a physical book, probably the cheapest way to go is to get the solar system version. There is a text for the lab as well. The lab uses an out-of-print book called the Astronomy Wilson Manual, and it's kind of like an activity workbook where we're going to do things together. Psst. I'm just going to make photocopies of the key pages that we need, and I'm going to give them to you, all right? So you probably don't have to worry about this. If you have it, if you want it, great, but it's out of print, so it might be hard to find. I don't use every page from it. I just use a couple of pages, and I kind of morph them to my own needs. So I'll be able to give those to you. You'll see that they're right in Blackboard under the lab tab. I'll explain that in a little bit. The other thing, the most important thing is honestly the Casio calculator, all right? That's the single most important thing you can get. Let me just poke into the chat log and make sure. Oh yeah, we do have lab today. Okay, let's go back to share screen for a second. Let's talk about how you earn points, okay? Showing up to lecture is worth 0% of your grade. That's because you paid for this, and that's when you come and listen to me talk. I'll be recording these, so if you ever miss class, you should be able to watch it and get the material later. The way you earn points is by doing work in this class. 25% of your grade comes from doing labs together. Now, our lab room, for all intents and purposes, I don't know if you guys can see my little window here, but we're going to go over to the lab room. That's my table there, okay? And that's where I'm going to set up different materials, and I'm going to kind of walk you through the doing of the lab, and you're going to record the values. And it won't be perfect, but it'll be good enough, okay? You'll get a sense of it. Lab is easy and fun. We do it together, and then as soon as you're done, you submit the work to me on Blackboard, and you start earning points for this class. Another difficult part of this class is doing homework. Homework is the real tough part, because if you try to do these problems on your own, you'll find that they're quite difficult. Every week, we have homework due, and the homework consists of 5 problems from the back of the textbook. So let's take a look at this other sheet that I gave you here. This is the most important sheet I'm going to give you. It's a mapping of our entire semester for the next 4 months. Today, Monday, August 30th, you're getting the intro to the course. We're going to have a lab on measurements and powers of 10. Actually, you know what I'm thinking, guys? Normally we're going to do lab on Tuesday, okay? And we're going to do homework on Thursday. But what I might do for this first class, is everyone okay with us doing the lab? I'm sorry, what am I saying? Tuesday and Thursday, Monday and Wednesday. I'm teaching too many classes. Normally we do the labs on Monday and we do the homework on Wednesday. But with everyone's permission, because we're going to run out of time soon, I think we're going to do our lab on Wednesday. Is everybody okay with that? Okay. So if anyone has an objection, tell me now, but I can't see why you would. We're going to do our lab on Wednesday after I've had a little more time to work with you guys. At that point, you'll have your calculator as well, so that'll be good. Okay, so let me use the rest of the time to explain how this works. So come over here and take a peek at this. Today, this week, we have class Monday and Wednesday. Our lecture is on the nighttime sky. I'm going to be following along with chapters 1 and 2. Our lab this week is measurements and powers of 10. The reason why you're not going to be doing homework this week is because next Monday is a holiday. It's Labor Day, right? So things are going to get weird. We won't be able to do a lab next Monday. So we're going to do our first lab on Wednesday. We'll do our first homework next Wednesday. But after that, every week we do lab on Monday and homework on Wednesday. You guys got that? This is going to make, if I were you, if I were a student, I would want to just hang out with my professor and do all the work and learn some stuff. And then when I switch off the computer, I'd like to deal with the rest of the problems in my life. That's how I would want things to go. And that's basically how I'm going to set this up for you. You can't screw up this class. All you have to do is just show up, okay? That's all you got to do. You couldn't get a better deal. Now, the homework problems, if you want to pregame them a bit, our first homework assignment, which we'll do next Wednesday, are 5 problems from the back of chapter 2. If you look at them right now, they're kind of seem crazy to you and probably scary. My goal is during the course of these lectures to teach you the materials you need to know to solve the problems and to show you how to do it. But even though I will explain that to you, you're probably going to still want some guidance from me. Let's take it from Frank, who's taken this class before. Frank, what's your thoughts on office hours?
Well, my thoughts, yeah, basically office hours are really good. And basically, obviously I passed your other class thanks to office hours.
But we're going to do the work together. It's not the worst time ever.
Mm-hmm.
Now, anyone who's suicidal enough to want to try to do the homework on your own, you can try that, but you're not going to like it, okay? You might as well do it with me because you'll get it done faster, better, and cheaper, okay? And I built it into the time you were going to be here anyways. Okay, good. So let's talk about one other thing here. The only other way to earn points in this class, besides the lab and the office hours, which we're going to, or the homework, which we're going to do together, is by 2 very scary exams. 1 midterm exam and 1 final exam. And each of them is worth 25% of your grade. They are going to be scary and terrifying, but you'll only have to do it twice. And the good news is, if you've been coming and doing the homework in your office hours and paying even a small amount of attention, you will be trained to handle test questions because the test questions will be similar to the homework questions. So as long as you come and you do your labs and you do your homeworks with me and you're not a huge flake, that's the moral of this story. Don't be a flake, okay? You can just show up, watch Astronomy TV, submit a couple of documents to me, and you can pass this class with flying colors. And you might even learn some stuff along the way too. That would be nice, okay? Thank God I'm not an art teacher, okay? I'm not here to like look at your sculpture at the end of the semester and say, I don't know, B-. It's not like that. Your grade is an objective system dependent on how many assignments you turn in and how many numbers you give to me. I kind of set up the Monopoly board and you're just going to walk around it and earn me some points, okay? Or earn yourself some points. So at the end of the day, your grade is an average of the homeworks and the labs and your midterm and final grade. But if you do the homeworks and labs with me, you're probably going to get 100s on most of them or something very close to that. And that's going to make your grade really puffy and it's going to keep you from screwing this up. So I'll tell you this, the only way you could even come close to failing this course is if you just flake out and don't do stuff. So don't do that. Just show up and hang out with me and I'll take care of the rest. And the best part is if you did get sick or if something happened, I'm going to put these videos up onto YouTube every day. Now, once our lecture ends, I stop the recording. It takes about an hour or so for the video to process. I will post them to YouTube, and I will post the YouTube link to our Blackboard. So you can catch the rerun if either you miss something or if you missed the class. Does that make sense? Okay. Let's take a moment here. I want to get to gallery mode. Okay. I'm running out of time quickly here. So it's, oh no, wait, this class goes until 1. What the hell am I talking about? I'm still used to the summer session thing. Our class goes until 1. That's very good. Okay. Do you guys have any questions about what we just learned? Does anyone want to ask a question to me about how your grade is determined? I wanted to sort of spell that out. Okay,
I kind of actually want to know how we're going to do the midterm in the finals. Like, since the class is online and everything, so it's kind of...
Right, because Bella, when you took it with me, we had the class...
Well, we had the midterms, and we took it in class, yeah.
Oh, then, that's right, and then we didn't do one for the final. Yeah, because we
didn't do a final, yeah.
Okay, so it's Bella, right? Bella's the nickname. Like, okay. Bella, I worked this out during the summer, and it was actually pretty smooth. It took me a very long time, but I encoded my exam into a like an online multiple choice test on Blackboard. So the questions display, and you click the multiple choice answer, and you go through it. You have to kind of do it in one session, and I will be hanging out during the exam in case you guys have questions. We'll kind of all, I know in some of your classes, the professors just tell you, go do the exam and whatever. But I think we're all going to schedule a time to, we're going to do the exam during class time together. That way I'm sitting there with you in case you get messed up or have questions.
Is there a time limit to it?
Well, to answer your and Heva's question, yeah, the tests are, well, here's what I did during the summer. You'll have like a few hours to take the test. So I will use a Monday session of lecture plus lab so that we have a full like 3 hours to do the test.
Okay.
And in theory, you would complete the test in those 3 hours. But what I did is I let people who are still really, really slow take a little extra time if they wanted it. But I stopped helping after 3 hours.
I only asked because during last semester, one of the teachers I had, she literally put like an hour of like for finals, and I wasn't able to even do half of the questions she had.
I could see that being a concern. No, that doesn't sound right. My test is long. It's 100 questions. The average person can do it. Most people can do it in under 3 hours. Only a few people who work very slow would take more than 3 hours. And at that point, you're kind of hemming and hawing too much, and you need to kind of choose. You need to do it, all right? But most people can easily do my test in under 3 hours. And for those of you who need a little extra time, I'm not opposed to giving it to you. So it won't be that you have crazy numbers of questions and it times out in an hour. I could see that being very frustrating. But our class begins at 11:30 and our lab ends at technically at 3. So during that session, you'll have 12:30, 1:30, 2:30. You'll actually have 3.5 hours. And last time there was a couple of real slowpokey people. I said, okay, I'm checking out now, but if you want to keep working on the test, you can just submit it to me. I mean, at some point you're going to get hungry and tired and want to stop. So I don't think it's going to be quite as bad as it was in that class. No quizzes, Heva. Here's something about me. I kind of hate assessment. I think labs and homeworks are really important, and I think tests are a drag. But I kind of need to test you, otherwise I would just have no way to evaluate you other than like whether I liked you personally. That would be kind of messed up, okay? So the tests are unfortunately a little evil and necessary, but we're gonna have as minimum assessment as possible. I want most of this class to be us hanging out, learning together, talking to each other, and doing stuff. I think that's how this is gonna work. So I think you guys will find this is a pretty low stress experience, with the exception of taking those 2 tests. We're putting all the stress into 2 classes, okay? And no, you don't, Heva, you don't need any access code or anything. You know why? Let me show you how this is going to work. Every time we do a homework together, we're going to go into Blackboard here. So follow along on my screen if you can. Here's homework. I need to update a few of these, but here's our first homework problem. It's 5 problems from the back of chapter 2. And I even gave you a photocopy of the problems from the book, so you can right click and open this in a new tab. And I photocopied the page so we can see what questions we have. Hey, excuse me, guys. I've got a hair in my mouth. That's unpleasant. Okay. You can see here, your first homework question is new planet. A planet in another solar system has a circular orbit and an axis tilt of 35 degrees. Would you expect this planet to have seasons? If so, would they be more extreme than Earth? Why or why not? Now, you're not going to know the answer to that yet. I've got to train you on it. But some of our questions, Heva, are word questions where we're going to write a paragraph or two. And some of our questions are math questions where we have to like do a calculation. Not only will I train you on how to do that, but then during our office hour session, I will do the bloody homework with you. So you know how to do it because we're going to do it together. Like I said, the only way to screw up this class is by being a flake. If you don't show up to the homework sessions, if you don't show up to the lab sessions, if you don't turn in your assignments, well, then you're a flake and you're going to get it, okay? Don't be like that. Just show up and do the stuff and it'll be fine. And if you do have a catastrophic experience, if you get sick, which is a worry in these times, you'll have recordings and I'll work with you to give you some time to make it up, all right? But you don't want to get in the habit of trying to do all of the work at the end of the semester because 1, I won't allow it, and 2, doing homework in labs, it's kind of like eating a meal. You can skip 1 meal and like eat a little bit more later, but you can't not eat for a week and then try to eat a week's worth of food in a day. It just doesn't work like that. And that's the same with classes too, okay? Okay, so anyways, no, you don't need any special access codes. I've given you everything you need to do, and I'm going to do it with you. So it's going to be cool. All right, let's spend the rest of our time together today learning a little bit of stuff. Okay, I'm going to teach you guys, oh, let me show you one other thing. About the lecture notes. A few of you who logged in early, I told you that in addition to your syllabus and your schedule, I have a section here called lecture notes, where I give you a kind of crappy Roman numeral outline of what we're going to talk about during the day. You have just had lecture 0, which is an introduction to 1010. And you'll notice I kind of talked about all these things, right? These are not all-inclusive study guides. I think you guys should have a notebook, and anytime I write something down on the board, you should write down what I write down. That's going to be very good for you. But these are to kind of give you a sense of what I want to talk about today. Now we're actually going to get into astronomy, and we're going to begin our lecture 1, Numbers on the Nighttime Sky. You'll notice that I provide you some useful things like some conversion factors and stuff. So these sheets can actually be helpful from time to time if you want to quickly look up one of the things that we talked about. You might want to get in the habit of even printing these out and keeping them in front of you. Let me say one other thing about the lab. And this could be another reason why it's good for us to do lab together on Wednesday. You will need, or you'll want to have a printer to print out your labs. So each day when we do lab, here's our first lab, Powers of 10. And this is the Powers of 10 PDF. I'm going to assume that a great number of you have a printer. And so what you would do is you would take these worksheets, you'd hit print, you can do the work on the worksheets, and then when it's time to submit them, you'll usually take your phone and you'll take a photograph of the assignment, and then you can email me that, or sorry, do not email me the assignments. That's going to be too crazy. What you do to submit your work is you go to Blackboard, and under homework, if you click Lab 1, Powers of 10, this is just for those of you who aren't too familiar with Blackboard. It's probably worth doing this. you can take a photograph and you can upload the file there and you can submit me the images. Now, some of you guys have crazy iPhones. You need to go into your camera settings and you need to select most compatible as your format, because I can only read JPEGs, PDFs, and .docs. Let's say there are some of you who do not have a printer at home. One thing that you could do in that case is you could try to convert this to a Word document, and you could potentially type in the answers. But I need you guys to use an equation editor if you're going to do that. I don't know if you guys know this, but you have access to tools like Microsoft Word and stuff. How does this work? There's somewhere here, there's a little box. Maybe it's in your, oh yeah. If you're in your email, do you guys see this 9-dotted box, which is called App Launcher? You can launch apps from here like Microsoft Word, okay? So this is me launching Microsoft Word right over the internet. Now you'll be able to open up the lab sheet here, but when you do math, oh God, new blank document. Bear with me here, I'm not that good at this. Okay, let's say you're gonna type up some math for me. I need you guys to do the following thing. I need you to use an equation editor. My computer's running a bit slow here, so bear with me. You go to, so for instance, I don't want you typing math like this, 2 times 10 to the power, what the hell just happened? Okay, I don't want to see math that looks like this. That's garbage and I can't follow what you're doing. When you're typing in math, you're going to use an equation editor. You're going to insert an equation that should be up here somewhere. I know where it is in the normal symbol. Where's that bloody equation editor? Equation. Looking for insert equation. All right. Okay, well, I'll figure out how to do it. This is this kind of.
That might be something you can only do in the downloaded version of Word, not the.
Yeah, like if I was doing it here, I would know exactly what to do, right? I would go, well, here, let's push this down. So here, I had to install my equation editor toolbar. So here I would go to insert equation. What? Oh, it's because, you know what? This is not a, all right, file, new document. It's because that's an older document. Insert, there we go, insert equation. And here I would type 2, and then you can actually get a time symbol up here. 2, this is probably really boring, you guys, but this is not, this is relevant to our class. This is important. 2 times, it doesn't take that long to do it. So 2 times 10, it's actually kind of fun, to the power of 2. So this is what I want your math to look like. I want your math to look like the way it does on the board. Look, for most of you, this isn't going to be an issue. Most of you are going to print the stupid sheet, you're going to write it with your pencil, and then you're going to scan it or you're going to photograph it and you're going to email it to me. Those people who do need to do this because they don't have a printer, we can have like a little breakout session after class one day, and I'll show you how to do that so I'm not boring 50 people at a time. Does that sound good? Okay. The first homework submission is going to be a little bit of trial and error. You can't just submit anything you want. There are 3 particular formats I want. I want JPEG, PDF, or a Microsoft Word document. Those are things that I can easily read, okay? And honestly, PDFs and JPEGs are the best. All right, let's learn a little bit about astronomy. Let's begin by talking about where you, how much time do I have left? Maybe 20 minutes at best. Okay, so let's start by learning a little bit about the orbit of Earth. I'm going to start off with a couple of slides for you guys here. And I'd like to start by having you guys look at, hold on, I've lost my mouse. Sometimes the mouse disappears. Oh, it's because I'm in PowerPoint mode. There we go. Function F5. Boom. Do you guys know what this is? What am I looking at? Who knows what this is?
Stars.
Not just, okay, yes, these are stars. But it's more than just stars. There's like, this is a famous grouping of stars. I just
The
want
Milky Way.
Not, these stars are in the Milky Way.
Galaxy?
Andrew. Well, they are in our galaxy, but it's something else. Oh,
Isn't it Orion's belt?
Austin and whoever, it's not just Orion's belt, it's the whole damn constellation of Orion, or most of it anyways.
Oh.
Orion is a hunter constellation. Here are the 3 stars that make up his belt, but there's also a big star called Betelgeuse. That's one of his shoulder blades. Here's another one of his shoulder blades. Bellatrix. Down here we have Saiph, and we have the great blue star Rigel. And so these are his 2 shoulders. This is his belt. These are either his feet or his kilts, depending on how you want to think about it. Sometimes he's holding a bow up here, and he has an arm with a club that kind of got cropped. Now, you cannot see Orion every single night. You can only see Orion at certain times of the year, usually in the winter time and in late autumn, and sometimes in the early spring. But right now, you cannot see Orion up in your local sky. That's because Orion is up during the day. I want to teach you guys not only what the constellations are, but how to tell when stars will rise and set in your local sky, how to go out and look for them. And that's practical stuff that will teach you how to be able to become familiar with your nighttime sky. For me to do that, we're going to have to learn a bunch of basic terms together so that we can have an intelligent conversation. You're going to learn how to talk about stars, how to talk about the rotation of the sky, and you're going to learn how to deal with large numbers of objects. These are skills that you need to have so that we can talk to each other. And that's the goal of our first class or 2, is to learn some stuff like that. Let's start by learning some basic things about the difference between solar systems and things that aren't the solar system. So, for instance, this is a legendary image of what was known as the Pioneer plaque. The Pioneer plaque was attached to the Pioneer spacecrafts, which were the first spacecrafts to leave our solar system. And we put a little plaque on it so that if aliens ever found the spacecraft, they would have a pictographic representation of where the spacecraft came from, so they could try to understand the history of what it was all about. And with that spirit in mind, let's start here. You live on planet Earth, okay? And planet Earth is one of 8 planets in our solar system. Our solar system consists of the sun, 8 planets, and then a few dwarf planets like Ceres in the asteroid belt, Pluto and Eris, and there are a few other dwarf planets as well. The solar system also contains asteroids. The asteroid belt is between Mars and Jupiter. The solar system also contains comets, some of which are out here. That's called the Kuiper belt. And there's another realm of comets which surround the solar system. That's called the Oort cloud. I'll teach you about that later. That's the solar system: the sun, the planets, some asteroids, and some comets, and a few other tiny bits of debris. What if I left the solar system? Where would I be then?
In the Milky Way?
That's good, Matt. Absolutely. And the Milky Way, if you zoom out from the solar system, is a vast assemblage of not only stars like our sun, but also of many other, okay, a galaxy is comprised of stars and the planets that go around them, but galaxies are also comprised of gas. A galaxy contains tremendous quantities of hydrogen gas. That's what makes a galaxy different than a solar system. It's not just stars and planets, it's a bunch of gas. And the stars and the gas are all swirling around each other in a flattened disk we call our galaxy the Milky Way. Our sun is located roughly 30,000 light years from the center of the galaxy. So we're kind of out here in the suburbs. There are many stars that make up the Milky Way galaxy. And that's going to be one of our first lessons that we have to teach the class. The number of stars in the Milky Way galaxy is close to 1 trillion stars. Hopefully you guys can see the chalkboard okay here. The number of stars in the Milky Way galaxy, 1 trillion stars. 1 trillion is kind of a big number. Does anyone know how many zeros are in 1 trillion? I don't expect everyone does, but I was hoping somebody did. Number of zeros in 1 trillion. Didn't someone chat me and say they were good at, sorry, Austin. Rory, were you saying something?
Isn't it 12?
Very good, Rory. I like your moves there. Okay, so Rory has identified 12 zeros. Let's write that down together. A 1 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 stars. For most people, 1 trillion is kind of a big number, okay? It's probably more than the number of zeros in your bank account. Otherwise, you wouldn't be sitting here hanging out with me. You'd be drinking a pina colada on Venice Beach, okay? Now, let's take a look at our Casio calculators together. Where did I put mine? Watch these moves here, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. You want to know what that means to me? That means that your calculator has 10 decimal places. And that means you could not put the number 1 trillion naturally into your calculator. But 1 trillion is actually one of the smaller numbers we're going to use in this class. So we're going to need a better method of describing big numbers than the old-fashioned method of just writing it down. Okay, that's not going to work for us anymore. And that means it's time for your first lesson. And your first lesson is how to write big numbers in a compact form. This is probably the only lesson we'll have time for today, and then I'm going to run out of time. Lesson 1 is on scientific notation. Some of you will have had to do this before. I don't care. You're going to learn it again, and you're going to learn it good, and you're going to learn it right, so we can have intelligent conversation with each other. Let's make use of some powers of 10. And let's diagram this number out so that I can talk about it later. This number here, this number is called your lead digit. The lead digit is the first number in your number. As long as it's not 0, the lead digit is the first number in your number. Then you have the number of zeros. This is an important part of a number. The number of zeros is what a scientist would call the order of magnitude. Let's write that down. The order of magnitude tells you how big your number is in a loosey-goosey sense. Is your number of order 1,000, 10,000, 100,000, or 1,000,000? That's your order of magnitude. And then last but not least, we have a really key part of our number. This is called the unit. The unit is a little tag that tells you what you are measuring. Units are of extreme importance in science. Every number that you've ever heard in your entire life, whether it's the number of dollars in your bank account or whether it's the number of teeth in your head, every one of those numbers is a measurement. The units tell you what the hell you are measuring, and it keeps your brain straight. You will always write down units in this class. If you don't, I will take off points until you learn. That's important to me, okay? Okay, we're going to make use of powers of 10 so that we can compact this number. And here's how that works, okay? You'll remember from some ye old math class that 10 to the power of 1 is It's 110. You might think of 10 to the power of 1 as a 10 multiplied by the number 1, which you can either express or hide. It doesn't really matter. 10 squared is 10 times 10 times 1. And that's, of course, 100. 10 cubed is 10 times 10 times 10, and that's 1,000. Eventually, you'll start to understand the pattern here. Every time you raise 10 to a power, like if you raise 10 to the power of 4, you get a 1 followed by 4 zeros. 10 to the power of 5 is 100,000. Okay, class, you try it. What's 10 to the power of 0?
10.
No. 10 to the power of 1 is 10.
0.
0.
Aha. Some people say 0. But let's go to our chat log. Christian knows the answer. It's not 0, but weirdly, 10 to the power of 0 is 1. This is a weird math thing, okay? That's right, Cam. Listen, people tend to think that 0 is the default number in math, probably because 0 is the default number in your bank account. But in mathematics, 0 is not the default number, but 1 is. And one way to think about this is if 10 to the power of 1 is a single 10 multiplied by 1, 10 to the power of 0 is no 10s, but the 1 is left behind. This is just a weird freaking rule from math that only makes sense after you've had time to think about it. Any number raised to the power of 0 is 1. Exactly, Heva. These are things we're going to learn. And some of us were remembering, some of us are learning it for the first time. In any case, it's actually more useful to us that this is true, because we can now represent any single number in terms of scientific notation. So let's clean this up. Let's see how this works. Okay, here's what I'm going to do. I'm going to start by writing down my lead digit, 1. Okay? And then I'm going to take my number of zeros and I'm going to pack them into a power of 10. I have 12 zeros, so I'll do 1 times 10 to the 12. And then I'm going to write my unit down, because I always write down my units. 1 times 10 to the 12 stars. That's how adults say 1 trillion, okay? That's how grown-ups say 1 trillion. 1 times 10 to the 12. And I don't want you to think of this as a math problem. Easy peasy. I want you to think of this as a compact way of writing a trillion. Now, in order to punch this into your calculator, I'm now going to, this is why I need you guys to have your calculators. Every single class from now until the end of the semester, I'm going to teach you how to do something different on this thing. I need you all to have this. Can we all promise that we will have this by Wednesday? If you don't have it, you're going to be wasting your time. Okay, thank you, everyone. All right, so that's why, by the way, that's why I was planning on doing lab today right up until like 10 minutes ago, when I realized if I do lab on Wednesday, that'll give all of you 2 more days to get this calculator. So everyone's cool with that plan, right? Show me the thumbs up if you're down with a lab on Wednesday this week. Okay, cool. Hopefully the night class is going to be there too. So listen, the key that I'm going to teach you, that's the most important key, thank you, Autumn, is the EXP key. So let's learn about how this works. When you write scientific notation, you write this. But on your calculator, the way you would type it is you would type 1 EXP12. And your EXP key means basically times 10, okay? So watch me do this. 1 EXP12. You'll notice that the calculator does not put in the times 10 because that would waste space. When you see it displayed, the display on your calculator looks like this. 112. Now, I'm here to tell you, when you submit homework to me, you will write this, but you will never, ever, ever write this, or especially not this. Writing that down on your paper is particularly offensive to me because I speak math. If you were to write down 1 to the power of 12, does anyone know what that means to a person who speaks math? What is 1 to the power of 12?
1.
Yeah, because it's 1 times 1 times 1 times 1 times 1 times 1, and then 6 more of those, okay? And 1 times 1 times 1 times 1 is 1. If you write this down and you meant 1 trillion, I'm not going to understand that. I'm going to look at that and my brain's going to interpret it as 1. So you can't write what's on your display and you can't write what the buttons are. You actually have to translate, that's your job, from calculator into proper math speak. Now, that might be a little awkward for some of us at first, but you will learn. Otherwise, I'm going to take off points until you learn. Okay, that's how this goes. Let's try one more example, and this is probably going to be the last thing I have time for because I'm right up against the edge of the clock here. Let me show you one more example of what you would do if you had a weirder number, something that wasn't quite so easy looking. So let's just grab a random number, a number like 98765432110. Now, you guys know the rules. If the decimal point is here, you put a comma after every 3 numbers, right? Who knows how to say that number like a grown-ass adult? Can anyone actually read that out, you know, the way you're supposed to from grade school? I'm sort of testing your competency level here. I don't know if maybe you guys don't even know what 1 + 1 is. I have no idea. You got to talk to me so I can figure that out.
Isn't it like 1 million and then like so on? I mean, sorry, 9 million.
This is the hundreds place, the thousands place. This is the millions, and that's the who's talking to me? Who's I hearing? I'm sorry?
Me, Juan.
Oh, Juan. Where are you, Juan? I'm looking for you. I just want to see your little face in my box here. Damn it. Juan, I can't find you. There's too damn many of you. Okay, Juan, but I can hear you. So Juan, read this number out for me.
9 trillion.
No, it's 9,876,543,210.
Whew, okay. Yes, nicely done. 9,876,543,000. All right. This is a big number. It's an annoying number, and it's the kind of number I don't want to see written down on your paper. What's your lead digit?
9.
Right. So we write down 9, and then what we do is we put a decimal point after, and we keep all of this number like the change, okay? 0.8765431. You can omit the 0, okay? And then we multiply it by times 10. And basically what we're going to do is we're treating all these other numbers as if they were actually zeros. Or another way to look at it is my decimal point starts off here, and I'm moving it until it gets over to here. And that means the number of zeros is how many times you move the decimal place. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be 9.8765431 times 10 to the 9, or 9.87 billion times 10 to the 9. Now, let's say you were a pesky student and you wanted to criticize and say, I don't know, bro, that number there, that looks even worse than this number. Why did you make me do that? I'd say, okay, you got a point. You got a point. It looks a little bit worse, all right? But you're missing something. You're missing the bigger picture. This part of a number here, it's different than the order of magnitude. This is what a scientist would call the precision of your number. It's how good the measurement is. And honestly, this precision, You usually don't need to keep all of these numbers, especially in astronomy, which tends to be a rather low precision science. I'll explain that later. Normally what you're going to do in this class is you're just going to round off to 2 significant figures, which means that you keep the 9 and you keep the thing that comes after it. Now, I do hope that somewhere back in the day, y'all learned some good rounding rules. If I chop a number there, right? If the first number that I'm chopping is less than 5, I leave this number alone. But if the number that I'm chopping is greater than 5, which it is here because it's a 7, I increment up 1. So the way that I would actually write this number would be 9.9 times 10 to the 9. And therefore, I could take this number and I could represent it as 9.9 billion. That's how we talk. That's how we do things, okay? In time, because we will do this together many times, you will learn this and you will learn why it's good. The last thing I'll do for you before we end class is I'm going to give you guys a little cheat sheet on some common powers of 10. Now, you're going to notice this is something I love to do in this class. So while you're out buying your calculators, I want you guys, because I know this is going to be helpful, do yourself a solid and invest in like a 50-cent crappy plastic ruler. Make sure it has some metric stuff on it, okay? Some centimeters. And you'll notice that I love making tables. I love making tables. And this is going to be one of your first tables. We're going to use this all the time. It's going to be some common powers of 10. There's going to be the name of the number, 10 to the power of x, and then we're going to list the metric prefix. Just bear with me here. And we are going to do trillions. We're going to do billions. We're going to do millions and thousands, okay? Sorry, I'm just. All right. So let's do trillions, billions, millions, and thousands. A trillion has 12 zeros. We've learned that already. So it's 10 to the power of 12. How many zeros are in a billion?
9.
Good. How about a million? 6, says Heva. Very good. And then hopefully everyone knows that there's 3 zeros in 1,000. Okay, what about the metric prefixes? For instance, when I talk about the metric prefix, 1,000 can be represented in the metric system by the prefix kilo. A kilogram, for instance, this is a kilogram, is 1,000 grams, hence kilo. Do you guys know what the metric prefix for a million is?
Mega.
Very good. A megabyte is 1,000,000 bytes. I like it when you guys know things. That makes me happy. How about a billion?
Would it be a giga?
Very good. A gigabyte is 1,000,000,000 bytes. A trillion?
Tera.
Very good. Do you know what 10 to the 15 is?
Nope.
It's a peta, but whatever.
Peta.
There are names for all crazy large numbers. These are the ones that we're going to use all the time, which is why I'm making a cheat sheet. Trillions, billions, millions, and thousands come up a lot. From now on, in this class, we're going to have a rule. And the rule goes like this. Any number which is greater than 1,000,000, any number which is greater than 1,000,000 must be in scientific notation, okay? So when you turn in homework to me, I will allow you to write down 999,999, and I'm okay with that. But as soon as it increments into 1,000,000, you write 1 times 10 to the 6, okay? That's a rule that's gonna keep us sane. Thank you, Hava, I appreciate it. Okay, let's go back to gallery view here. Class, this is pretty much all the time we have. I kind of used up every damn minute of it. And I spent a lot of time on the intro. Forgive me for that. But this is good. We actually got one little mini lesson today done on scientific notation. Now, here's my thoughts, okay? I originally intended to do lab today, but our first lab is going to be on using the calculator to multiply stuff in scientific notation. And my thinking is, how many of you don't have the calculator? Can you show me with your hands? There's kind of a lot of you that don't. And I get that because you had no idea what I was going to say to you your first class. Why don't we all get the calculator and we'll do lab after class on Wednesday because we don't have to do homework this week, okay? Now, I have another thing to talk about before I end class. Are any of you registered for the night class? No one, okay? I'm going to send a special email to my night class. I am going to have them watch the videos that I make during the day with you. I'm going to invite them to join us if they can, but probably they can't. They're probably working. But I don't want to repeat myself twice in a day because it's going to make me insane, all right? And since the lectures can be delivered synchronous or asynchronous, they're going to watch the videos. But I'm just saying for the point of the recording, for those of you who are watching later in the night class, I'll meet with you specifically today, but from then on, you're going to watch these videos that I make during the daytime. And if you can sneak away at work, if your boss isn't looking and you want to call this up in a window at work, then you can join us live then. That works, okay? Okay, once I end class, the Zoom will render this into a video, which I will post to YouTube, and I will post that to the announcements section of our Blackboard page. So those of you who miss class or need to review it, you can go to Blackboard and under announcements where you can see my little intro video here, each day I'll post that video, but it's going to take about an hour or two for that to render and complete, okay? Do you guys have any questions before I see you guys on Wednesday? Anything you'd like to ask or? Cool. All right. These will be long, hard days, but we can do it together and we can learn some rad stuff. So thank you for your time. Please go out. The most important thing you can do for this course is to get that Casio calculator. Wednesday's time, Andre, will be the same as today's time. I will send out a Zoom link, which apparently you all got. I'll try to send it out 10 minutes before class. We'll all log in. We'll do a lecture from 11:30 to 1, and then we'll do our lab from, the lab is supposed to go from 1 to 3, but I try to make it a little bit quicker than that so I can, you know, just so we can speed things up and get on our merry way. So I try to get the labs done within an hour. Sometimes they go a little over, but they'll never go to 2 hours. And that means at the end of the class, if you want to talk to me about stuff, if you have like personal stuff you need to talk to me about, you know, we can have a one-on-one thing. I'm always available to talk. You got my number, you got my email, whatever you need. Okay, so yes, all right. Unless there's anything else, I'll end it and I'll see you guys Wednesday. Look for the Zoom link in your emails 10 minutes before 11:30, okay? Okay, live long and prosper. I'll see you guys on Wednesday.